Good morning, children. Welcome back to ICAN Physics. So, in the third video from the second lesson, we are going to study about the relation between current and drift velocity. So, simply you can get the mnemonics NEET. Okay? Okay, fine. So, the next one, the relation between current and drift velocity. Relation between current and drift velocity. Okay, so let us consider the conductor xy of length L when it is connected with the external source. Okay, so that the conventional current flows from higher potential to lower potential. Now we are establishing the electric field from X to Y. Then the electrons are drifted from Y to X, which is opposite to the direction of electric field. Okay. So now we have studied F equal to MA. F equal to EE. Okay. Section. Mu equal to drift velocity acquired per unit electric field. That is equal to E tau by M. Okay. Like that, when we derive, finally we can get I equal to NAE into drift velocity. Just we can go for the mnemonics. NAE, NAI, VD, VD, NAI, VD. So, is the relation between current and drift velocity. Okay. So, from that we can say current is directly proportional to number of electrons. The current is directly proportional to area of the conductor. The current is directly proportional to drift velocity. Okay. From that, we can get into Ohm's law. So simply we can go for Ohm's law, but I want to go in a deeper manner. Okay. So I equal to NAE into drift velocity. So for instead of drift velocity, we can substitute E tau by M into E. Okay. So NAE into drift velocity. That is E tau by M. In the division E comes to this as multiplication E. Now E into E, it becomes E squared. NAE squared tau by M into E. Okay. So we know very well that is E equal to V by L. That is dV equal to minus E into dx like that. So E equal to V by L. So for instead of E, we can write V by L. So I equal to NAE squared tau by M into E. So for instead of E, we can write V by L. Okay. Now this term is taken as constant. Okay. That constant is taken as I equal to 1 by R into V. So now the division R comes to this as multiplication. So V equal to IR. Now we are going for the second mnemonics. That is vegetarian sapravar IR. Okay. So V equal to IR. So what is R? R is the resistance. So what is resistance? That is prevention of flow of current. Okay. So the multiplication I comes to this as division I. So V by I equal to R. So what is the unit of resistance? That is ohm. Unit of resistance is ohm. So what is the unit of potential? Volt. Okay. What is the unit of current? Ampere. So volt per ampere is equal to ohm. Volt per ampere is equal to ohm. Okay. So V equal to IR. That is Ohm's law. So what is Ohm's law? At constant temperature, the steady current flowing through the conductor is directly proportional to potential difference across its end. At constant temperature, the steady current flowing through the conductor is directly proportional to potential difference across its ends. Okay. Same manner, we can define resistance. Resistance is defined as the ratio of potential difference across its end to the steady current flowing through the conductor. Okay. So, what is the dimensional formula for ohm? Okay. So, ohm equal to volt per ampere. Okay. So, where we have seen volt, then dV equal to minus E into dx. So, V is volt. Here we can write Newton per Coulomb into dx is a length. So, unit of length is meter. Okay, for Newton, F equal to MA. So, kilogram meter per second square divided by Coulomb, ampere second into meter. Okay, so kilogram meter into meter square. The power plus 1 goes to the numerator as minus 1. Already having, having minus 2. So, second power minus 3. The power plus 1 goes to the numerator as minus 1. Okay. So, this is the equivalent unit of volt. Okay. So, now we can convert kilogram, M, meter squared, L squared, S power minus 3, T power minus 3, A power minus 1. This is for volt. So, what we are going to calculate? Ohm. Okay. So, ohm equal to volt. So, for instance of volt, we can write M, L squared, T power minus 3, A power minus 1 divided by ampere. Okay. So, now the power plus 1 goes to the numerator as minus 1. So, M, L squared, T power minus 3, A power minus 2. This is the dimensional formula for ohm. Okay. Do you get it now? Do you have any doubts? No doubts.